right. Welcome all. I'm Neil Davis, lagrev-nocfep on the network, and I'm here with the mopfel-winrux, who
Hello.
that always sounds to me like a character out of The Wind in the Willows or something.
I love the Pat P.
When I say it aloud,
I love the Pat
what
P.
does it mean to be mopful?
I don't know. That's why you love it so much. It can mean anything.
You need to discover this for us, because there will be a lot of other mopfuls coming into the world as Urbit proceeds. So we are here to talk about a new vane, a new part of the kernel system, which will be lick. This is the first vane that has been introduced since Con, which I believe was 2022. It might have been late 21. I don't remember exactly when Con came in, which has handled threading and given some new affordances for working with threads. So Mopfel has been the primary author of and architect of lick. So tell us what lick is supposed to do. What problem does it solve for us that we weren't able to previously do with our Urbit ships?
So a big philosophy of Urbit was that, Mars shouldn't call Earth of some sort. And this is good in theory, but in practice, you have the HTTP vane, which kind of destroys this. This allows user space apps to open an inter-process communication port on the host computer. So this allows user space apps to call Earth as long as the Earth app speaks nouns. So it's a pretty useful vane. It lets regular Linux processes or Mac processes have an interface into Urbit user space apps, or any Urbit software in general.
Now, vanes often evolve quite a bit once they start to be written. I know that the initial spec and the final product of Con, for instance, evolved a fair bit. So what was the original aim of this project, and then what did it become in its final version?
So originally we called it Lock. I think you and I first started talking about it in like December of last year. And the goal was a hardware control vane. This is a vane that will talk directly to hardware through a language hardware speaks, which is just byte streams. And it was going to use a Unix system call called IOCTL or IOCTL, IO control, however you want to pronounce it. And this provides an interface to write struct-like data into files to control hardware. This is how Linux exposes devices into user space. So, this was great, except for a couple of composability and security bugs, which caused that. We had a working prototype. It was pretty cool, but it caused it to kind of get put to the wayside for this favor towards nouns, which I think at the end actually made it a lot more of an interesting vane, because it opens up a lot more than just hardware control.
Yep. And speaking to something that we discussed a little bit pre-show, I think that it's also good in that it limits the surface area of protocols that are getting encoded into the kernel, right? Like the things that we put in vanes are now under Kelvin versioning, which means in a sense they're intended to become permanent.
Yeah, exactly.
And trying to encode IOCTL and UART and Bluetooth and everything else into your vanes would ultimately become kind of a mess were you to go down that road. So instead, lick speaks IPC, especially since IPC has been around for decades, and Urbit currently only runs on host OSs that are Unix-like in nature. It seems like this is a reasonable bet for our substrate for the time being. So what is it? I guess what do we want to look at now? What it can do? What it can? What does the code look like? There's,
Yeah,
we could get pretty nerdy down into, what does the C code actually look like? Maybe we'll do that if we have time at the end. But yeah, let's look at like, what does lick do? You were showing off a demo with your thermal printer being controlled by it. There's been an app that was done in a build party recently. So let's pull up your screen and see what would be neat to look at here.
yeah. Let's actually look at the lull file because I think that makes the most sense. Let me just bring it up. So this is the interface that is defined for lick here on the right side. So the lick interface is pretty simple. An app can send a spin card to lick that essentially says, "Hey, Lick, open up this IPC port and then send me any data that comes through it. And then any data I send to you on this port name, go ahead and jam it and send it to the IPC." So you have a spin and shut, which opens and closes the port. You have spit, which spits out data. So this lets you send data out. And then soak, which lets you bring back data. The soak comes in on an on arvo. So you just modify your on arvo arm to look for that, which we can see how we modify the snake game for that to work later. But pretty simple interface. It extends the poke idea to the port, so you have a mark and a noun. So you get to define your own interface. The assumption is if I have a Gall agent installed, I will have an Earth software that understands and knows how to speak that when it connects to it. By default, there are 3 soaks that you have to accept. A connected soak, which basically tells you, hey, some Earth process is connected to you. A disconnected soak tells you some Earth process is disconnected, and an error soak. And right now, the only error you can get is, hey, nothing's connected, can't talk to this. But we can see a future where different errors might get created as people play with this and experiment.
What is so the name is a path. Is that like /dev/
Yeah, so it actually gets stored in so if you go to where's the CD ls dot, you have in your .erb folder, so you now have a dev folder, and this creates a file path. So it always puts so Gall will intercept the let me make that so you can actually read it. Sorry. Gall will actually intercept an agent card and prepend the agent name to it. So every agent has its own file or folder location on Earth. So you can see the app Slick has a control file, so it's a path. So it'll actually create the whole folder structure for you for that app inside of it.
So what does this look like from Urbit's perspective? When we were talking about the hardware vane stuff originally, one of the scenarios that we had thought through was to what extent does Urbit talking to a device or a process behave like networking, right? Where you're sending a signal and you don't actually know if there's a connection on the other side available, if you'll ever get a response. Like ACKs in hardware devices look a little different than the network stuff, but like from an Urbit side, how does it know if something's connected when the runtime spins up? How does it know that it's maintaining what's going on and so forth?
That's actually so if you do it at a hardware, what original idea was to do it at a hardware level, and if you did that, then you don't really know if something's connected or if it's working or anything. But because we brought this up to a higher level of abstraction, you actually do know when something is connected to the IPC port. So you're not talking directly to hardware, but you're talking to an earth process that can translate nouns into, say, a hardware code. So similar to what I did, similar to the receipt printer, what it did is it took a noun, a tape, and basically decoded the jam noun and just sent that through in a UART connection to the printer, and it printed it out. Now, that earth process can do the checking to make sure things are available, and it'll crash and will never connect to the port. So the Urbit side doesn't really know, if it doesn't really care at the end of the day. Now, it gets its on connect mark. It assumes whatever it can connect knows what it's talking and knows how to handle its interface.
Okay, so how much code did you have to write earth side for the thermal printer process to work?
Well, because it was in Python, we can look at it. How do I spell receipt? I think I called it printer, actually. No, is it lick? There we go. Yeah, so because the printer was just a serial Adafruit timer, I was able to pull the just regular libraries for it, declare an object, and this is, I guess, the main loop here, that while it's true, it reads from the socket, it actually takes that data and passes it back to var to do a queue on it. This is because we didn't have a good noun library at the time. But then it just basically took the pretty printer and decoded it into, and did the translation. So not much. This is what, 60 lines of code in Python? Most of this was copy and paste, so not much, right?
As much as we may deplore the ball of mud,
yeah,
there's something to be said for just being able to spin stuff up in Python.
Yes, yeah, especially for non-networked stuff, it becomes really easy. I don't know. Sometimes it's nice to spin stuff up in a simple,
There's probably some philosophical debate to be had about Earth and Mars, consorting freely with each other this way. But so what does, so I guess when the IPC processes an event and emits this back in, then that's what comes in as a soak through your on-arvo arm, and that's what you have to process.
Mm-hmm.
Does that come in as a raw noun? What exactly does that look like to the communicating process?
So when you connect, you just get an on-arvo, so you get a sign arvo, and we just check to see if it's a soak. If the mark is a noun, in this case, we start, we spit out the control state and start the timer. Well, we wait until we get a control. But yeah, you can see on an on-connect, we do something, it comes in just as literally a marked noun in an on-arvo. So you have a cell, the head is a pat TAS, the tail is any noun that you're supposed to know how to decode.
Does this use like a mark cage system at this point? Or
no.
Is it, okay. It's
no.
just you're getting a noun and then you have to do like a zap gal or a mic style descent back into regular space.
I know an error is a pat TAS, so I just print it out.
Yep. All right, very cool. Yeah. Let's actually, I guess, do you want to show off Snake and then we can talk about the code implementation some?
Yeah.
This was built last Friday or 2 Fridays ago, I forget. Was it the 9th? Was it that recently?
Yep.
Gosh,
no, it was 2 Fridays ago.
It was the 2nd.
Yes.
Yeah, it was the 2nd. Okay. This was built for one of the Urbit build parties. in a single session. Mastier Botek contributed some planning, and then mopfel-winrux wrote this in about, what do you think, about 4 hours, 4 or 5 hours?
No. The snake game itself was from Prowl.
Right. Yes.
Yeah.
So there's an Urbit text snake game that's available with the 2E tools branch of the Urbit repo. It's just a demonstration. It does work. It runs in DIL and everything. What was set up here was a Pygame external interface to that game, and then a lick bridge to communicate between those two elements. So this is another example of using Urbit as a back end of some kind to a front end that is now no longer a browser client session. It is something new. It's a Python instance running a Pygame interface.
Yeah, exactly. So we can see space to start WASD. You see up there on the top left, you see that time step is about once every 2 seconds. That's hard coded into Urbit. We can change that, but it doesn't work as good. The controls are actually hard coded jams nouns that get passed in, so there's no calculation that needs to get done to jam or queue those. But the state is actually calls var every frame, so it's very slow. I still haven't gotten to Python. Fraud was put together a nice Python noun library, but it doesn't have the newt stuff, so I need to just add that to it. You can see playing Snake, I can hit myself and I crash. Start a new game and try again.
So what's happening right now is you have a front end interface, and when you are using your arrow keys, these are sending head tagged nouns, or I guess just not even head tag now. Like the tag is the
control.
Control, and then there's a pat TAS direction affiliated with it that is updating the inner state, and then Urbit is sending the current state back out to Pygame to render.
Yep. Exactly.
So really, all Pygame is doing is keystroke handling and then rendering. It maintains no state of its own.
Exactly.
What it needs for the display.
Exactly. And on a crash, it gets a crash command and just game over. We should display that, but we don't. I'm not getting this, but yeah. There we go. Fun little snake game. Yeah. But you can think about expanding this to a lot of other things too, right? Like, let's see, it opens up video control, right? You can technically write a Python or any Earth process to start a WebRTC session of a camera and feed that information back into the Urbit network.
Well, there are, back to our initial inspiration for Lock had been, can we write hardware controllers, hardware cryptographic dongles, all these kinds of things. And this, it pushes it to a different level of abstraction, as you pointed out, but it does enable those kinds of operations. So now we can actually imagine, there's like a Trezor bridge or a ledger kind of operation that we want the Urbit to talk to carry out certain transactions. So you could have a fully secure, Bitcoin wallet app that's mediated by your hardware device that your Urbit uses for transactions.
Exactly. And I mean, this pushes that this pushes at least our philosophy at Native Planet that you need to own your compute. Mm-hmm. So you need to own I died. You need to kind of own what controls what you're running on, and at least at some layer. And Urbit enables this quite a bit, which is nice.
So what do you see as what's the future of Lick? And what is, Native Planet, you built this because you felt and argued that it was a necessary feature, right? It was a piece of Urbit's kernel that needed to exist. So what follows on as a result of that now?
Well, right now, I think in the immediate future, we're working on a way of controlling your hosting infrastructure from your Urbit. So we have a software called GroundSeg. This is basically a way of hosting multiple peers on any old computer. And the idea is now that you can designate a planet in charge, or a peer in charge, that will let you control, host, and boot up other peers that you can pass on to people and such. So I'll probably just work on some lore implementation with that. So you can boot up a bunch of ships and give them to your friends through a lore link. So I think that's in the near future, probably short term. Longer term, I think figuring out how to make IoT more secure is another one. So I have a doorbell. I have a Nest. Do I want Google to be accessing my videos and knowing when I'm not necessarily a Ring, and knowing when I enter and leave my house? Not really. So how do we make that more secure? How do we use Urbit as a backend for that?
Are there security concerns with having this vane in existence now?
No.
And if not, why not?
No. So there's two ways of really looking at. There's two big concerns here. The first is if I'm hosting my planet on myself. So if I'm hosting my planet on my own hardware, and for hosting providers, if I'm hosting someone else's planet on my hardware. So if I'm hosting on my own hardware, I should know what apps I'm installing onto. I should know what apps I'm installing into user space of Urbit, as well as what's running on my computer. So both of those things need to be active. You have to have the Urbit app installed and running, and then you have to have the other thing connect to it. So, and that's the same for someone else's hosting on my. If I'm hosting someone else's peers, I have to make sure that they're not running. I have to make sure nothing's running that's going to connect to that IPC port.
Mm-hmm.
So no, unless someone probably can tell me that there is some, and we can discuss it, but I don't think there really is. And we've kind of designed it in such a way that there wouldn't be.
Now, Alex Dosrow points out in the comments, the risk would be the same as giving someone access to the user running the ship, I guess.
Yes, exactly.
Which is, yes, if you're compromised at the level of access, then you have issues.
Yes.
So now we can talk about different kinds of external control processes for your ship as well, right? You can use your ship to run things, to interface with hardware and so forth, but now you can have external triggers for things taking place as well.
Yeah.
And these could be, I'm imagining, there are definitely like processes or hardware can trigger certain conditions. I think there's some interesting ramifications in terms of UKBAR style smart contracts where now we can have real world conditions, trigger an event in Urbit, right? That they take place.
I think that's I think the other way around of looking at it might be better. You can have smart contracts trigger real world events.
Sure.
Which
is, both ways, right?
Well, I don't know. I think that one now opens up a whole new. I think Ted and I talked about this before, but it's I have a lock on my door that opens up for an hour when money gets sent to this address. Mm-hmm. I now have a truly decentralized Airbnb.
Right.
But you can also think about it. You can think about the other way, but I always think about how can an event on my Urbit affect something in real life? Either give me access to something or remove access from it. But I guess the other way around I don't know. What did you have in mind for the other way around?
Well, the other way around would be something like, you present a token or a dongle, you've connected. Now, the Urbit triggers an event or a smart contract, or whatever you have as a result of that. Right, I've got a coin, and presenting this coin to some reader or something is allows me access to my Urbit, for instance.
I
Right,
like that.
now I have hardware mediated access.
Yeah. Ooh,
Or
like
there are certain processes, I can do whatever I want, but if I want admin level access to this Urbit, then I have to plug in the dongle.
Yeah.
Or biometric, or whatever.
No,
Right,
I like that.
now we can differentiate different levels of permissions as a result of having these triggers and capabilities.
Something else that might be also interesting is, once we get a bigger loom, is recording data on your Urbit, right? Since it's a functional, you now have a way of just inputting sensor data or machine readouts into user space,
Mm-hmm.
and into your Urbit. If you're doing any sort of data transformation, you have a record of it, right, in your event log, which is an interesting thing to think about as well. Replication and such.
Do we have questions from the audience? There aren't really any questions in the comments right now, but if y'all have them and you don't want to save them until the chat afterwards in the gather, go ahead and drop those in. Yeah, let's see. So Lick is out there. What does testing and validation look like for a vane?
So there are a few levels. The first was just making sure the interface works, right? So writing a bunch of, echoing bad cards, echoing bad data and such into the vane to make sure things crash properly and things get caught. Once the interface was worked out, then really honestly the Urbit side is the easiest part. I thought so, at least. Vanes are deceptively simple once you get the hang of them, which is, it makes sense, and they should be, right? But the Earth side, the C code, requires I think it still needs one more review before finalized, but like making sure we don't have memory leaks, making sure we can like exit gracefully or recover on a bad exit, etc. is all important as well. And then there's a usability testing. It's kind of useless to have a vane with like a crappy interface. Then no one will really use it, right? It has to feel comfortable for users to use. So that was kind of the idea behind the receipt printer. Initial test out of it. We did some testing. We did some testing with internal to native plant to see if the interface would work for our use case, and that's also what Slick was for. And we did the hack build party to see if it's easy and understandable for users to use.
Yep.
Scott,
all right.
Yes.
Fantastic. Let's see. Okay, yeah. So Scott, could Lick be used to shut down a ship, upgrade the binary, and restart?
Yes, you can. There are multiple ways of doing it, right? Naively, you can have just another Earth process outside of Var that monitors the port for any sort of upgrade command and does that. Another way of doing it would be to actually have Var have something in the base desk that emits an upgrade command and have Var connect to it. And technically the binary can get passed through Arvo as well in either of those situations, which makes it interesting as well. Right?
We're going to want fast aims if we're sending binaries.
I know. Well, that's what Vane is for.
Right. Yeah. All right. I don't see any other questions right now. So let's wrap this discussion here and move to the Gather Town. Let's see. Do we have a link ready for the Gather Town invitation we can drop in the comments there? and we will have a face-to-face with everyone who wants to drop in on that. So thanks, Mopfel. What's
Yeah.
next?
Well, let's see. Hope be on the lookout for command and control of your hosting from Urbit. That's going to be our big thing. And then check out our boxes. They're easiest way to self-host your Urbit. We made it as turnkey as possible.
Should have had a picture for your.
I know, we should have. That would have been cool. But you can click on the website and you can see all the pretty pictures. And yeah.
All right, I guess I'm just waiting on making sure that the gather link gets dropped before we shut down the stream as well. Let's see. Yeah, I've been interested in, and I've done this with JavaScript and some other website stuff before. I've been interested in, sort of what is the minimalist set of changes that has to be made to an existing interface to get Urbit to work as a backend for it.
Yeah.
And this will be fun to play with in that regard. Actually,
we have a last minute question.
Yeah. Jake asks, can multiple agents connect to the same IPC port?
No, because they are blocked off by agent name, they cannot. So I'm assuming you mean agents on GAL agents when you ask that. But yeah, no, each agent has its own user space, has its own path. So no, that's not possible.
Oh, the idea that I had, and I may want to try this for a build party at the end of July or August, is I want to hook blog or publish up to Obsidian for publishing via Lick.
Ooh, that would be fun.
So,
we should do that.
Yeah, so we'll be able to watch a directory, and any change in that directory gets pushed immediately to blog, publish, whatever you want to push it out in.
I like that.
And then you can use an existing Markdown optimized tool to produce your Urbit content.
That's a good one.
I want to play with that. Like next month with a build party. Joe Bryan says, in their integration with Lick, GAL agents are servers, not clients.
Yes. Yes, that is correct.
Blurring lines all over the place. All right, the GatherTown link is in the comments there. We will decamp for that, and thank you, Mopfel, and we look forward to seeing this drop with the next Kelvin decrement, I believe, is what it's planned for.
Yeah, end of this month, I think, or early next month.
I think early July is the next time we're gonna decrement. So
excellent.
All right, see you all in Gather.
Yeah, see you guys.